Okay, I think it's the time for us to start this session. I guess everybody can hear me well. Okay, good. Hello, everyone. Welcome to this XC 2022 demo session on Android and web application. So, this is Guowei Yang. I will be the chair of this session. We have 3 wonderful 2 demos in this session. So to give you a quick summary of the format, each 2 demo will have 15 minutes in total, including 5 minutes for a brief presentation, as well as 10 minutes for live demo and question and answers. So when you have any questions, feel free to type your questions in the chat, or you may ask questions directly to the presenter during the Q&A session. And in the end of this session, in case we still have time left, we will open that for more questions and discussions on any of those 2 demos. So the first 2 demo is about Gallery DC, auto-created GUI component gallery for design search and knowledge discovery. So Monash University will present it. Sudong, when you are ready, please take over and start your presentation.
I may share my screen first. Okay. Can you see my screen and hear my voice?
Yes.
Good.
Looks perfect.
Okay. My name is Sudong from Monash University. I will present our work, Gallery DC, auto-created GUI component gallery for design search and knowledge discovery. First, I would like to have a brief recap for our motivation. Graphic user interface is an essential part of software application. It provides a visual bridge between an application and end users through which they can interact with each other. A good application easy, practical, and efficient to use, which significantly affect the success of the application and the loyalty of its users. To design a good GUI, designer usually start with inspiration search from existing designs. However, despite the innumerous amount of design search engines, it is still difficult for designers to efficiently get inspiration and understand design knowledge due to the lack of 3 requirements. First, existing design sharing platforms showcase creative design artwork, but designers also need to see the practical use of the certain ideas in real applications. Second, existing design sharing platforms tend to support the sharing of the overall design only, but designers want to search for both the overall design and the detailed design of the GUI components. Third, designers want advanced design search capabilities and knowledge discovery support beyond simple content sharing and search. To address the information needs of designers, we design a new way to collect, analyze, search, summarize, and compare GUI designs of real-world applications on a truly massive scale. We built a web application for our GUI component system called Gallery DC, which is an abbreviation of Gallery of Design Components. In detail, our approach consists of 2 main phases to manage the database in the Gallery DC: application GUI screenshot collection and GUI component decomposition. We collect 2 kinds of application GUI screenshots. One is annotated runtime application screenshot that is collected through automated exploration method to capture the screenshots and dump their metadata. However, collecting these runtime application screenshots can be time-consuming, and simple inspecting these screenshots cannot effectively exploit this goldmine of GUI design resources. We find that the application introduction screenshot in market usually illustrate the most important feature and the best design GUIs of an application. And also, it is easy to collect. Therefore, we build a web crawler to retrieve the application introduction designs from markets. In total, we collect a massive scale of GUI screenshots. After deriving the screenshots, we next decompose the components in the GUI. It is straightforward to decompose components from annotated runtime application screenshot that contains components metadata. However, the application introduction screenshots are purely images. Therefore, we train a deep learning model on annotated runtime screenshot to detect the components in the introduction screenshots. Lastly, I would like to annotate some tool implementation and usage in our website. We provide several convenient techniques for users to search, analyze, and compare the GUI designs to gain inspirations, such as multi-facet search, design demographics, component information, and last but not least, design comparison. We summarize our contributions as follows. First, we explore a new goldmine of design resources, which is application introduction GUI screenshots, representing some best features and best designs. Second, we propose a new way of design sharing and design knowledge discovery complements existing design sharing platforms to extend them beyond content sharing. And that's all for our paper. And thank you for listening. Feel free to try our Gallery DC and provide any feedback. Okay, so what's going on next? Should I?
Yeah, please go ahead and do the demo.
Okay, I just show our Gallery DC. So I just start from the homepage. Maybe it's a little bit slower due to the network latency.
Sidong, can you hear me?
Yes.
Yeah, please. Maybe I think you haven't switched.
Switch the.
So yeah, maybe you have to reshare it.
1 second. Okay. Can you see right now?
Yeah.
Okay. So it's the homepage for our Gallery DC. So basically, we have a simple abstraction for our system and providing some good GUI designs in our database. And furthermore, just some basic introduction. So I probably start to explore some functionalities of our website. So the main functionalities of our Gallery DC is you can search and gain inspirations. So we provide a multi-facet search layout, so you can select different widgets and you can choose any colors you like, and you can specify your application category you want to search. And also we support that, such as like supporting by different order, and even you can import some text you want to specify to search. So after you have all the information insert, you can just click on the search, and it's where a little bit slower due to the network. Okay. It's where first show you a demographics, a design demographic for all the search results. For example, we only search for the class of bottom right here, and the main colors for all of the search results, and it's purely for the blue, and also some distribution of the height and width of the components. and then you can have a deep look on what's the search result for. There are lots of components you can you can have a look. And if you find any interest components, you can just click on this. For example, for this component. So it will show the detailed results of the components. First, we have the screenshots that we have a bounding box that highlight this highlight the search result and the overall design of the of that search of that component. And we also have some show some detail like the package category and even some text in the components and some color of the font of the font it's used to display the text. And also we show some similar components that according to that widgets you can get more inspiration. And if you find that information is really interesting, you can also share by Twitter or Facebook or Pinterest. Yeah. And that's all for the functionality of search. So another main functionality of our Gallery DC is you can also compare between companies. For example, if you are interested in like what's the design idea between like Microsoft or some big company, you can just add the companies into the compare list, and it will show the result. Okay. First, it will show like what's the application, what's the main application of the company that's mainly focused on, and any application categories, and what about the rating of their design, and some detailed designs that they use, and it is mainly provide some insights between the company's level. Yeah, and that's all for our website. And you can also contact us if you want, if you find any interesting ideas or some feedback to our gallery. Yeah, and I'm happy to answer any questions.
Thank you. Any questions? Yeah, while people are typing their questions, or maybe they're thinking about questions, I have a quick question about the tool. It sounds very interesting, and I guess it's open to public, right? So have you received any kind of feedback about the usefulness of the tool, since you released this tool or released this website?
Yes, we have received like several feedback from the large company like Google or the Microsoft, and they overall they prioritize our website and help them to get some interesting feedback. So one of the interesting feedback is that they find that they can search a lot of the component level. They can get inspiration from the component level. Like in general, they only get inspiration from the Dribble or some a Pinterest that only provides the overall design, overall GUI only. But when they design some specific ideas, they need to gain inspiration on the component level. But there are there does not have any design search engines provide that functionalities. But well, with our system, they can just search from the component level and bridge to the whole GUI level.
Mm-hmm. Wonderful. Yeah, so any more questions? So you do not have to actually to put your question in the chat. You can actually unmute yourself and directly ask the question to Sidong if you want. Okay, if we don't have questions, we'll go ahead and move to the next talk.
Thank you.
Thank you. Yeah, thank you very much. Our next two demo is about proactive libraries enforcing correct behaviors in Android apps. Oliviero Giornelli from University of Milano Bicocca will present it. So let's have Oliviero take over and start his presentation.
Hi, everyone.
Hi.
Can you see the presentation?
Yes.
Yeah, I can go ahead. Okay.
Yes, please go ahead.
In this talk, I'll present proactive libraries, an approach to enforce a runtime the correct use of APIs in Android applications. Failures in Android apps are very common. If we just consider crashes, we can see that almost 1 out of 4 apps crashes. And most of these crashes are related to APIs. This is due to the fact that 25% of all method and field references in the app code use the Android APIs, and these APIs evolve fast, and developers struggle to understand and update their code to incorporate new API changes. A study that analyzed the discussions on Stack Overflow found that the biggest challenge is using the APIs within the lifecycle of an event-driven Android object. This is unfortunately a big problem because current verification and validation practices fail to detect many lifecycle related problems that can cause apps to fail. The goal of this work is to protect users from problems caused by app developers who don't use API correctly. The idea is to introduce a proactive module that is able to detect and correct misuse of APIs at runtime. This is an example of an event-driven lifecycle object. It's an activity. An activity is a basic component of an app that provides a screen on which a user can interact to do something, for example, to take pictures. An activity can be in different states, and when there is a state transition, a callback is invoked in order to handle Android events. For example, when an activity is paused, the onPause callback is invoked, and an app developer can override this method to release, for example, unused objects. In the Android documentation, we can find many policies that specify how to use APIs. In this slide, I just reported 3 examples of policies that explain how to use APIs to avoid waste of resources. For example, the Android documentation specifies that an activity, when paused, must release the camera so that other apps can use it. If these policies are not met, we may experience problems. For example, assume that an activity wants to acquire a camera that has not been released by an activity that is paused. This activity will receive a runtime exception that, if not handled, can lead to a crash of the app. The idea is to augment the classic libraries with proactive modules that are able to detect when a policy is not respected, as in this case, and correct the execution, in this case by releasing the camera. To do this, we introduced proactive modules that can intercept interactions between apps and libraries to automatically correct them if they violate an API usage policy. At development time, the developers of proactive modules first identify the policies that need to be enforced. These policies are then formalized and encoded into enforcement models. These models specify how to avoid violations of policies. The proactive modules are finally generated from enforcement models and deployed in the operational environment. An enforcement does edit automata. An edit automaton is a finite state machine that specifies how to change an execution by adding or suppressing actions. The label above the transition represents the intercepted method call, while the sequence below a transition indicates the method sequence executed by the proactive module when it intercepts the method call specified above the transition. The edit automaton in this slide represents the enforcement model for the camera release policy. Assume that we are in state 0 and a faulty app required to acquire the camera. The proactive module intercepts the call to the open method and performs it, reaching state 1 without, in this case, altering the execution. At some point, the activity is paused, but the camera is not being released. And so the proactive module intercepts the on-pause callback, which is performed, and then adds the call to the release method of the camera in order to not violate the policy. The proactive module is then generated from enforcement model by using a switch case pattern. The generated proactive modules are exposed modules, and exposed is a framework that allows to intercept method invocations and change the behavior of an Android app at runtime. To facilitate the generation of proactive modules, we develop a tool that implements the core responsibilities of a model-driven software development environment. These responsibilities are assigned to two main components: the AMA editor, which implements modeling and validation responsibilities, and the PM generator, which implements the code generation, compilation, and deployment functionalities. Using the graphical editor that is based on Eclipse modeling framework, developers can generate and validate enforcement models. These models can be automatically mapped into exposed modules and deployed to the target environment. To do this, the PM generator uses Aselio to generate code from models and Gradle to compile and deploy exposed model in the target environment. At this link, you can download and try the proactive libraries. And for more information about proactive libraries, you can read the paper Controlling Interactions with Libraries in Android Apps through Runtime Enforcement. Let's see the tools. Oops. Okay. This is the M editor that proactive modules developer can use to model the enforcement strategies. Here we are modeling the enforcement strategy for the camera release policy. We have two states, and now what is missing a transition. We can add the state and transition using the collect. What is missing is the transition from state S1 to state S0. Is the one that have to modify the execution if the camera is not released. And so the action that we have to intercept here is the onPause method. Okay, here the intercepted action is the onPause. You can see now we have a prefix that is after. After means that we want to intercept the end of the execution of the method onPause. And now what we have to do when we intercept the onPause and we are in state S1, we want to complete the execution of the onPause and release the camera. Now we have finished the a simplified version of the strategy to release the camera. We can validate the model. In this case, we don't have problems, but for example, if we put, for example, a method that doesn't exist, and we try to validate the model again, we get an error because this method. So let's fix this problem. And validate again the model. Okay, we don't have problem, and so we now can generate the proactive module using the PM generator. To generate the model, we have to select the edit automaton, and then we have also to select the generator. At the moment, we have only developed one generator, that is the one that can implement proactive modules as exposed modules. Then we can type a description for the module, and we can start the generation process. This takes time, but I have already deployed this module on the target system. And so if we open a faulty app, for example, FUCAM, okay, I have a delay, maybe too much virtualization. Okay, it doesn't work. Sorry. Okay, it doesn't work now. I understand why. Okay, I can try to restart the emulator. Okay, I'm sorry for this. Okay, now we can see that the code has been generated. We can start also with the deployment. We currently deploy the model directly to the device, but in a realistic scenario, we expect the user to be able to download the modules from a dedicated store and apply it in their devices. Okay, maybe there is. I'll try again. I hope now it's working. Maybe there are too much virtualization. The emulator doesn't work correctly. I can try now to reopen the FUCAM app. Okay, it's very slow. I don't understand why. No. I'm so sorry for this. Maybe if you have a question, I can try to.
We can ask some questions for Olivier while the system is still running.
Okay.
Yeah.
Okay, it's still running now. It's open the app, but I don't know
now?
why it's opening the app now, but it's very slow, the emulator,
Right.
and so the emulator seems doesn't work now.
Mm-hmm.
Okay, no. It doesn't want to work. It's very slow now. I'm sorry.
That's fine.
But anyway,
yeah,
you can see the video. In the video there is the demo that I want to show you now.
Yeah, so for those who not familiar with this thing, on the ICSI website we have this program schedule, and you can click the paper and find the video. I guess there's a long version of video for this paper. So yeah, there also should be some demo there to look at how it works. So yeah, so do we have any questions for Olivier?
Okay, sorry, since now it's working.
Oh, okay, cool.
Okay, it's opened the camera. This is the dummy camera, okay? And so we can put the app in background. I hope that it's now working. Okay, we put the app in background, but the app doesn't release the camera. And so if we open another app that wants to acquire the camera, what we get an error because the camera is not available. What we can do now, the user can decide to activate the proactive module for this faulty app because he doesn't trust it. Wow. Why? Okay, sorry.
Still some problem there?
Yes, maybe we are done, and so we can open the dedicated. We can open the dedicated app. We select the Fuka Maps. We can activate the proactive module. We save this, and now the proactive module is active. We can reopen the Fuka Map that now acquired the camera. Oh, maybe more fast than before. Okay, we have this some delay on the. Anyway, it acquires the camera. We can put it in background. Open the other apps that want to acquire the camera, and now the other apps can acquire the camera because the proactive module released the camera acquired by the other apps. Okay, I finally completed the demo with some delays on the emulator. I'm sorry for that.
That's fine. Thank you. Do we have any questions? So I have a quick question here. So it seems that the user need to do a couple of things to make this tool working. So can you briefly explain like what kind of knowledge does a user need to have to use your tool?
From the user of the app doesn't need any knowledge because maybe he can download the modules from a store and can then deploy it on the target environment. What we need, we have the proactive module developers that can know how to model an enforcement strategies by using an edit automaton. This is the only knowledge that is required to the proactive module developers. And that's
so there's a possibility that the library, I mean for the user's app is not available, right? So then in that sense, the user has to kind of report it to you, so you generate the model for that user. Is that kind of how
it works? What I mean, proactive module developers can develop many proactive modules that can be in a store, and the user can decide which one want to download it, activate it, and when the user finds an untrusted app, he can enable the proactive module for that apps. How we did before, we have a FUCAM that doesn't release the camera, and so the user open the dedicated app, select the module to activate for this app, and then the system works there without any issues.
So let me clarify a bit here. So if you have a model, is a model kind of applicable to a range of apps, or it's only applicable for a specific app?
No, the module is it can be applied to several apps.
Okay.
To all the apps that use that APIs.
I see. Okay.
It's not specific for an app. Okay.
Yeah,
it's specific for the policy.
I see. Yeah, if you have it's specific to an app, then you have too many things to generate and solve.
Yeah. I know it.
Yeah. Right. Okay. Sounds good. Do we have any more questions? All right. Thank you very much, Olivier.
Thank you for your attention.
So our last two demo is about Navigoid, a tool for guiding manual Android testing while hint moves. Zhe Liu from Institute of Software at Chinese Academy of Sciences will present it. So when you are ready, please take over and start your presentation.
Okay, thank you very much. Okay, can you see that? Okay, hello everyone. My name is Liu Zhe. I'm from the Institute of Software Chinese Academy of Science. Today, I will introduce my research work, Navigoid, a tool for guiding manual Android testing when hint moves. First, as we all know, Android apps become more and more complex, and the automated testing often have some problems, such as low test coverage, single operation, and so on. To ensure the application quality, many companies also adapt manual testing as the last line of defense, and some software developers also lack the manual testing. Within the manual testing, testers mimic users' behaviors to explore different functionalities in the apps to find more bugs. And compared with the automated testing, human testers are able to discover more bugs, such as the UX bugs, UI display bugs, and the crash bugs, especially those related to the user experiments. So, and the crowd testing recently become more popular in the software testing. It can combine the benefits and effectiveness of the crowdsourcing and the cloud platform. However, there are also two problems with the manual testing. First, it is time-consuming, which requires a large number of testers to manually explore each screen of the app. And the testers may execute repeated actions during the exploration. Second, the performance of manual testing is unstable, as it highly depends on the tester's compatibility and the experience. And the testers may miss some minor functionalities, especially for those unfamiliar apps. Therefore, the target users of our research are the testers who are not familiar with the application they are testing. So, inspired by the automated testing, we developed a tool to get the crowd testers to test the app. And we also give it a fancy name named the Navigoid. It can get the testers like a navigator. During the manual testing, Our Navidroid will track the testers' testing steps and help them navigate or remind testers with unexplored pages by hint moves. It can help human testers avoid missing some functionalities or make repeat exploration steps. Now, when you input an Android APK, the Navidroid will first get the state transition graph. Then it plans the path of the testing. Follow the planned path. We use the hint move, just like the bounding box on the screen, to get the users to test the app. Then I will introduce our Navidroid with a demo video.
Do you want to know about a new app? Do you want to test all pages? We will introduce Navidroid. Let's start. Help you explore the app like a navigator. You just need to upload an APK. It will record your test path and get you to test. It has dynamic guidance, cost zero, and save your time. Please use our Navidroid. It can achieve high activity coverage, and users like it. What are you waiting for? Let's start with Navidroid. Navidroid will get you to explore the app by using hint moves. Navidroid will get you to understand the functions of the new app. Navidroid will explore the deeper UI pages with you. During the test, when you stay on an interface for more than 5 seconds, Navidroid will automatically plan the path and get you to explore the missing UI pages. During the test, when you don't follow the hint moves to explore, Navidroid will dynamically plan the path according to the state you have explored. We hope it can help you. Thank you very much.
Okay, then we evaluate the Navigoid, and the results shows that it has high state coverage and can save more steps. We further carry out a use study to evaluate its usefulness in assisting manual testing. We can see that it can save times and find more bugs. Okay, that's all. Thank you. If you have any questions, please connect us. Thank you very much.
Thank you, Zhe. That's a very interesting tool. Do we have any questions for Zhe? So if you have any questions, you can unmute yourself and ask Zhe
Yes.
directly.
Can you hear me?
Yes.
Yes, okay, I have just a question. What I understand, Navidroid helps tester in exploring the functionalities of an app under test, right? I'm right? Yes.
Yes.
But what I expect is that a tester has functionalities to test, and these functionalities are provided as input. So usually you have a document that specifies the test that you have to manually perform on the app, because you have to meet the requirements. And so I don't understand why the tester needs a tool to explore the functionalities of the app.
For this question, I think it's a good question. First, the target users of our Navidroid are the core testers who are not familiar with the apps. And you know that the core testers, they often test the app with rendering the random the test, and also have some and also don't have some knowledge. So we use this Navidroid to get them to test more pages, and they don't have the test just like the the text document and so on. So we use the Navidroid to help them.
Okay, I understand. What do you mean? It's for beta testing, for a tester that doesn't know the app, right?
Yeah,
How
thank
to
you.
use the app. Okay.
I also have a question here. So the thing I didn't catch the slide you showed. You know, comparing the coverage between different methodologies. I think you showed some like a comparison between techniques on the coverage. Right? So, and Navidroid achieved. It seemed that Navidroid achieves the high coverage. But just wondering, like, I guess you are using the static analysis of the code to generate the hints, right?
Yeah.
So how do you compare your, compare Navidroid with existing, this purely static analysis, some static analysis guided automated testing?
Oh, okay. I think it's a good question. Thank you very much. And the first step of the Navidroid is to get the state transition graph. So we compare the baseline with the state transition graph, and we first manually label the states of the of the apps, and then we collect the STG, the state transition graph of our Navidroid and other business. So we can use this.
Yeah. So I think some automated testing of Android has already used some kind of state transition graph to guide the automated testing, right?
Yes.
So what's the benefit of kind of combining this state transition graph and the user manual testing? So I think that's the key here. So what extra information you have, right, compared to those purely automated testing state transition?
Oh yes. The automated testing maybe have some single operations, and the humans can do some complex operations such as scrolling the wheel and so on, and input some text. So we use the manual testing, and we want to use the STG of the dynamic testing, and then we will use it to help the testers. And we found that they can find more bugs such as user experiments and such as UX bugs and so on.
Makes sense. Thank you. Yeah, quick question here that is your tool publicly available now?
Yeah, we use it on our code testing platform, and also have some feedback, and some developers also think, and some crowd testers also think it's good for them. And it's
Okay,
also
so
good
if we want to use it, how can we get that tool?
We will upload it on our crowd tester platform soon.
Okay.
Okay.
Sounds good.
Okay,
Thank you.
very much.
Any more questions for Zhe? Okay, so I think we still have some time for open discussions. If you have any questions on any of the 3 tool demos, please feel free to ask. Any questions? Okay. That's yeah. I think like you may not have questions for now, but in case you have more questions later, you may contact the authors directly via email, or have a virtual room that's available in Midspace. Okay, so all right, I think we will then go ahead and wrap it up. Once again, let's thank all the speakers again for their excellent presentations.
Thank you.
And also thank you all for joining this session. I hope you will enjoy the rest of ICSE and see you around in other sessions. Bye-bye.
See you.